Okay, so question 6, left hand side is equal to cot theta plus cosec theta all squared. Now, when I considered this, I looked at what, I thought about cot theta, because if you think about cot theta, it's actually cos theta over sine theta, yeah? And when I thought about that, I reasoned, of course, well, cosec theta is 1 over sine theta, so we've actually got then the same denominator, okay? And the good thing about having the same denominator then is we can write it as a single fraction, okay? So I'm not actually going to expand this with a double bracket to get 4 terms. I just kind of realised, because that is cos over sine, this can have the same denominator as this. And then you can write that then as, cos theta plus 1, yeah, on the top, and sine theta on the bottom. Okay, so it's a single fraction with a common denominator of sine theta. And then what you can do, okay, you can actually square each term individually. So you can square the top, so you get cos theta plus 1 all squared, and you can square the bottom, so we get sine squared theta. Okay. And then we need to think about sine squared. How could we rewrite sine squared? Because we've got to look at the answer, haven't we? And there's no sine in there, but of course we know sine squared can be rewritten as, well, if we use the identity sine squared theta plus cos squared theta equals 1. So sine squared, of course, then will be 1 minus cos squared theta. Okay, so we can rewrite this as cos theta plus 1 all squared over 1 minus cos squared theta. And then another way of thinking of this denominator is appreciating that this is actually the difference of 2 squares. Okay, so we could, in fact, if I just write a longer fraction line here, we could write the bottom as 1 minus cos theta, 1 plus cos theta, because this is the difference of 2 squares. That's the square of 1, that's the square of cos. So we could rewrite the denominator as this. And of course, if we look at the top, that's just cos theta plus 1 all squared. And then we get a situation whereby we can actually cancel these. Okay, so that cancels with that because it's a common factor. And then you'll notice there we've got exactly on the top, and maybe I'll write it the other way around, 1 plus cos theta, and on the bottom I've got 1 minus cos theta, which of course then will equal to the right hand side, and we are proven. We're done.